let us see what do you mean by solid. What do you mean by solid? A solid means we can say it is a three-dimensional object. A solid means it is a three-dimensional object which is having length, breadth, width or breadth, and height or thickness. Sometimes we can call it as a thickness, sometimes we call it as a thickness, height. Okay, length, breadth, and thickness or height. So when any object having three dimensions, then we can say it is a solid. It is a solid. Okay, right. In solids, in the drawing, in engineering drawing, to represent any solid in engineering drawing, minimum we require two views. So minimum we require two views. For example, if you take one block, so it is a three-dimensional object. So it is having length, it is having height, and it is having width also. To show this object in the drawing. So when object is observed from the front, you can see the front view. If the object is observed from the top view, you can see the top view. Similarly, when object is observed from the sides, you can see the side view. Okay. So here three views are needed to give the complete description for this object. In the front view, we can see the length and we can see the thickness. In the top view, you can see the length and you can see the width. And in the side view, you can see the width and thickness. That means, so minimum two views. Sometimes side views are needed and sometimes may not be. That is just to represent, for example, if you want to represent a cylinder or a cone, so for this two views are enough. So if you observe from the top, it is a circle, and if it is observed from the front, it is in triangle shape. But whereas the solids like cube, for prism, for pyramid, sometimes three views are needed. So therefore, in the drawing, to represent any solid, so minimum two views are needed. Sometimes more than two views are needed to give the complete details of the object or to describe the complete description of the object. Even sometimes, apart from three views, some auxiliary views are also needed to give the complete description of any solids. If the solid is having some complex shapes or to give more details about the solid, we may need more than three views also. So that is about the solid. Then what are the different types of solids? So solids are mainly grouped as, first we can say regular solids, and another one irregular solids. Regular solids and irregular solids. So regular solids means they will have some regular shape. Irregular solids means they don't have any particular shape. That is, solids may be regular solids and irregular solids. In regular solids, further it can be divided as polyhedras. It can be divided as a polyhedras. One classification. Another classification, you can say solid of revolution. These regular solids are further classified as polyhedras and solids of revolution. Then, if you go in depth with the classification, these polyhedras are further can be grouped as a regular polyhedras and other type of polyhedras. So now mainly the solids are classified into two groups: regular solids, irregular solids. So irregular solids means we will having regular shapes, and further regular solids are further classified as, are grouped as polyhedras and solids of revolution. And these polyhedras may be further grouped as a regular polyhedra, and other polyhedras. So what is the difference between regular polyhedra and other polyhedra? Means the regular polyhedras having all equal faces. All the faces are equal. But whereas in other polyhedras, the examples are, one is prism, and another one is pyramid. So here the bases or base may be in the shape of a polygon, and the lateral faces will be maybe rectangle, or lateral faces may be isosceles triangle. But whereas in regular polyhedras, all the sides are equal, lateral sides equal and the base sides are equal in size, then those are known as a regular polyhedra. So in regular polyhedras, so you can give some examples of regular polyhedras as a tetrahedron, octahedron. Okay, not necessary. Many the polyhedras, further grouped as regular polyhedra, and other polyhedras. So in regular polyhedras, so examples are tetrahedron, octahedron, before that hexahedron, octahedron, dodecahedron, icosahedron, like that. There are five types of regular polyhedras: tetrahedron, hexahedron, octahedron, dodecahedron, and icosahedron. Okay, but in drawing we will be dealing only with tetrahedron and hexahedron. But in the polyhedras, all the sides are equal. So hexahedron means it is nothing but cube. It is a cube. Tetrahedron means a triangular pyramid having all equal, height equal, width equal. That is tetrahedron. And hexahedron means it is a cube. You can see in cube all the faces are equal. So that is about the polyhedras. Regular polyhedron, tetrahedron, hexahedron, octahedron, dodecahedron, and icosahedron. Not necessary those things. Okay, here in other polyhedras, one is prisms, and another one is pyramid. So prism means, so it will be having two faces, that is top face and the bottom face, containing a regular polygon shape. It may be triangle, a square, a rectangle, a pentagon, or a hexagon, containing two faces, top face and bottom face. Bottom face having a regular polygon surface. Okay, and all the sides are lateral faces. Those are of rectangles. But whereas in the case of pyramids, the base is having a shape of a regular polygon, but all the lateral faces having triangular faces, isosceles triangular faces, all will be meeting at one point. I can show the example. So here, this is known as a prism. See here, the top face and the bottom face is having a shape of hexagon, and both top face and bottom face are joined by the rectangular faces. These are lateral faces, rectangular in shape. And if you take pyramid, the base is having a shape of a polygon. Now it is example of a square. It is in the shape of a square. It is a square pyramid. and these faces connecting the base are in the shape of a triangles, but in the case of pyramid, all these faces are meeting at one point, that is vertex point or apex point. So that is the pyramid and prism and pyramid. That is about the polyhedras, regular polyhedra and other polyhedras in which prisms and pyramids. Now one more group, that is solids of revolution. That means these solids are obtained. So when they are revolved. So in this one is cylinder, second one is cone, and the third one is sphere. These are the examples of solids of revolution. That means cylinder. So for example, if you take a rectangle, if it is revolved, if it is continuously revolved in the axis, you will get a cylinder. Similarly, a right angle triangle, if it is revolved in the axis, along the axis, you will get a cone. Similarly, if a semicircle is revolved about the vertical diameter or horizontal diameter, then you will be getting a sphere. Means all these solids are obtained when the surfaces are revolved about their edges or about their axis, and those solids are known as solids of revolution. Example: cylinder, cone and sphere. I can show you the So this is the cylinder. You can see the cylinder having a circular base, top face and the bottom face having a circle in shape, and these two are joined by the what you can say end generators. All these are joined. Top face and the bottom face are joined with the end generators. That is cylinder. Now coming to another one, that is cone. Having a circular base, and all these points on the circular base are meeting at one point, that is vertex. These are end generators. And another one is sphere. Okay. So, but we will be in drawing, we will be practicing the problems on cube. This is cube. Okay. And the problems on prism. So this is the prism, this is the cube, and this is the prism, and this is square prism. You see the difference between the cube and square prism. But in square prism, having a square base, but height is different. But whereas in cube, all the faces are having square with equal sizes, that is cube. Then, so pyramids may be having any shape of the base. If it is a pentagon shape, then if all the lateral faces are meeting at one point, then we can say pentagonal pyramid. If the square is, if the base shape is in the shape of a square and all the lateral faces are meeting at one point, then we can call it as a square pyramid. Similarly, prism. If the base faces are having a shape of a polygon, here it is a pentagon, and all the lateral faces are in the shape of a rectangles, and this we can call it as a pentagonal prism, square prism. So similarly, if a solid is having a triangular base, the two faces triangular shape, then we can call it as a triangular prism. So like that, depending upon the shape of the base, we can say that particular pyramid or prism. So similarly, there is one more thing. This is in rectangular shape, and height is different. This we can call it as a rectangular pyramid. And similarly, so here it is, the base is the shape of a triangle and the lateral faces are meeting at one point, then it is a triangular pyramid. So like that, there are different types of solids, right? Now in drawing, we will be dealing only with regular solids, not irregular solids, only regular solids. So what are those regular solids? One is polyhedras, they are prisms, pyramids, cylinder, cone, that's all, not sphere. Sphere is not included, only these solids. So we will be placing these solids in different positions and obtaining the views, that is front view, top view and side view, that is projections. And here one more term is there, that is, what is frustrum? What do you mean by frustrum? Frustrum of solid. Frustrum of solid and truncated solid. Frustrum of solid or truncated solid. So frustrum of solid means if any object, for example, if you take a pyramid, if it is cut by an imaginary section plane, so that the section plane is parallel to the base, and the remaining portion, after removing the cut portion, that is known as a frustrum. Right? Then what is truncated means a pyramid, whatever may be the shape of the pyramid, a prism or pyramid. If pyramid is cut by a section plane, so having some inclination with the HP, and if the cut portion is removed, the remaining portion, after removing the cut portion, then it is known as a truncated. So this truncated and frustrum of solids, the projections for this will be dealing in the next unit, that is sections of solids. There we can clearly knowing the what do you mean by frustrum of solid, what do you mean by truncated cylinder. Right. Now let us come to the projections of solid. So in solids, already you know different types of solids. Okay. Now coming to the projections, here we are practicing the projections of solids in engineering drawing in first angle projection. That means placing the object in the first quadrant and obtaining the projections. That is first angle projection. In first angle projection, this floor we can consider it as a horizontal plane, and this wall we can consider it as a vertical plane. Now object is placed in the first quadrant, and when the object is observed from the front, you can see the true shape on the you can see the projection on the vertical plane, that is front view. When object is observed from the top, the projection or view can be seen on the horizontal plane, that is top view. Already you know it. So now, positions of the solid. There are different positions, so that an object or a solid can be placed in the first quadrant. Now, so in the planes we have given the importance for the surface of the plane parallel to VP, surface of the plane parallel to HP, surface of the plane inclined to HP, inclined to VP, like that. But in the solids, we are giving importance for the axis. What is this axis? Axis means it is an imaginary line connecting the center of the top face and the center of the bottom face in the case of prisms. That is that imaginary line known as an axis. In the case of pyramids, so it is an imaginary line connecting the center of the base with the vertex, then that is known as an axis. So here, so sometimes we may be using the word right pyramid, right cone, right cylinder. Okay, so right pyramid means right pyramid, right cylinder, right cone, right prism means if the axis is perpendicular to the base, such solids are known as a right. That means right prism, right pyramid, right cone, right cylinder. Right? But we are not dealing with the oblique solids. That is, oblique solids is axis is making some inclination with the base. those objects we are not dealing here. So here we will be drawing the views for regular solids, right. Now coming to the present topic, that is placing the object in first quadrant and obtaining the projections. What are the different positions? Now this is the solid prism. So now already you know the axis, the imaginary line connecting the center of the top face with the center of the bottom face. That imaginary line is known as an axis. Now axis, if it is like this, if the axis is perpendicular to HP, like this, then the true shape you are obtaining in the top view. That means when the object is observed from the top, then only you are obtaining the true shape. That is axis perpendicular to HP. Then another question is axis perpendicular to VP. So when axis is perpendicular to VP, you can see the true shape in the front view. Right? Similarly, another question is when axis is parallel to both HP and VP. In this case, the true shape can be seen in the side view, not in the front view, not in the top view, in the side view. Right? Similarly, when the axis is inclined to HP, this is one more position, inclined to HP. So when solid is placed such that its axis is inclined to HP, then the true shape cannot be seen in the top view and in the front view. In this case, you have to assume that before the axis inclined to HP, it was perpendicular to HP. When axis is perpendicular to HP, already you know that true shape is obtained in the top view. You have to start the drawing with the top line. Then similarly, another question is axis inclined to VP. So like this, axis inclined to VP. So in this position also, in front view, you cannot see the true shape. In top view, you cannot see the true shape. Here, in this condition, you have to assume that before the axis inclined to VP, it was perpendicular to VP. When axis is perpendicular to VP, you can see the true shape in the front view. You have to draw the front view, then further rotating the top view, that is procedure. Right. And another question is axis inclined to both. Axis inclined to HP as well as inclined to VP. This is last position, axis inclined to both HP and VP. Okay. Now, if you summarize, what are the different positions of the solids which can be placed in first quadrant to obtain the projections? The first one is axis perpendicular to HP, at the same time parallel to VP. Second one, axis perpendicular to VP and parallel to HP. Second position. Third position, axis parallel to both HP and VP. And the fourth one is axis inclined to HP, at the same time parallel to VP. And the fifth position is axis inclined to VP and parallel to HP. And the last position is axis inclined to both HP and VP. So these are the positions. Axis perpendicular to HP, parallel to VP. Axis perpendicular to VP, parallel to HP. Axis parallel to both HP and VP. Axis inclined to HP and parallel to VP. And axis inclined to VP and parallel to HP. And the last position is axis inclined to both HP and VP. And here already I explained, axis perpendicular to HP and parallel to VP means the true shape you are getting in top view. Okay. When axis is perpendicular to VP and parallel to HP, true shape you are getting in front view. When axis is parallel to both HP and VP, you are getting the true shape in the side view. When axis is inclined to HP and parallel to VP, you should assume before axis inclined to HP, it was perpendicular to HP. That means U shape is obtained in top view. When axis inclined to VP and parallel to HP means before the axis inclined to VP, it was perpendicular to VP. That means U shape is obtained in front view. Then there is separate procedure for the last condition, that is axis inclined to both HP and VP. So these are the various positions so that a solid can be placed in first quadrant and projections are drawn. Projections are drawn. Now here, so when it is dealing with axis perpendicular to HP, perpendicular to VP. So now in the first case, axis perpendicular to HP here. So here there will be second condition. The side is perpendicular to VP. Side perpendicular to VP. Side parallel to VP or side inclined to VP. Inclined to VP. These three positions will be there. Whether it is a pyramid or a prism. Okay. So three positions. Side perpendicular to VP. Side parallel to VP. Side inclined to VP. In the case of axis perpendicular to, similarly, when axis is perpendicular to VP, here also this side, base side is parallel to HP, base side perpendicular to HP. So here better you can see. So perpendicular to HP, parallel to HP, and inclined to HP. Like that, you can draw the projections. That is front view, top view, and side view. You can draw. And another one is the axis parallel to both HP and VP, like this. So here also the one of its side is perpendicular to HP, one of its side is parallel to HP, and one of its side is inclined. So three positions you can draw. So you can draw the side view, front view, top view, for prism, pyramid, cylinder, and cone. That is simple positions. That is solids one. When it comes to solids inclined to HP, inclined to VP. Inclined to HP means before inclined to HP, you should assume it is perpendicular to HP, right? Okay. So now we will stop here. We will continue in the next video.